Howdy, y'all. Welcome to this talk on ensembles and ASR. I'm hoping we'll have a great time here, so let's get right into it. Who am I? What are we going to be talking about? Why am I here? First of all, I'm Jeff Susan Ward. Susan is a fun call sign that I've been using for quite a few years now. We're going to go on a little journey here, and we're going to be talking about ensembles, customization of ASR, and then putting it all together with custom ensembles, right? Start with a quick recap on the ensemble world, talk about what it means to customize a model and what we're trying to target there, and then how those two can work together, really help things out in the ASR world and solve problems for everyone in that domain. So first of all, I want to just say, despite the topic title, this is really interesting stuff. It's fun to play with, and it's fun to see these models kind of work together in a really great way to improve accuracy and make your use case better. So let's get over to the ensemble world. And also, just to reiterate, if you have any questions, like Sharon said, please add them at any time. We'll try to get them in QA session, but the more questions, the merrier. And if we don't get to them in the QA, I'll try to answer them offline afterwards. So I'm going to give you a quick overview of the ensemble world. I will do my best to avoid the standard that if you Google ensembles, you're going to get the same examples rewritten 14 different times. So I'll try to avoid that, and we'll just hit the high levels. The important thing to recognize about ensembles is there are three really big pieces: the data, the model, and the predictor. And in the data, the question there is how we're going to split it up during training. Not during inference, but in training, how we're going to split that up to train the various learners that are inside the ensemble. And then the predictor, how do we put them back together to get the best out of it? So in the ASR world, or in the standard literature, you'll find a bunch of different terms and all that stuff. Well, I'm going to get to exactly what we're going to do in the ASR world in a little bit here, because that's kind of part of the big idea and a little bit of a mentality shift that we're looking to do when we talk about ASR ensembles, right? So quick overview, like I promised, trying not to harp too much on that. So the customization, what does it take to customize a model for a specific domain? Well, when we talk customization, the reality is it's very hard to get a ton of single domain data. I mean, if you've got tens of thousands of labeled hours, great. You're well ahead of the game. You've got all sorts of stuff. But the reality is most solutions, they don't have that many. You have a few hours, right? So what we're going to do is we're going to start with a generally strong model already, something that's generally okay. And we're only going to take a couple hours to start with. More is always better. If you ask the data science as to how much data it'll take, they'll just say more. And we're going to specialize that model on that audio. And we're going to make sure that we hammer things like domain-specific vocabulary and trying to get those n-grams into the model that it really recognizes. And when I'm talking about training here, I'm talking about the end-to-end training. So depending on how you've created your ASR stack, you could have multiple models involved, acoustic model with a language model afterwards. When we talk about training, we talk about training the end-to-end, the whole thing gets hit with our training data here. But the important thing to point out here is we are intentionally biasing the model, right? Our goal is to really make this model good at that domain. And to not make it good generally anymore. In fact, we kind of want it to be a little worse general and start predicting your specific n-grams very easily, right? So let's go over what's the big idea here. The big idea is, with custom ensembles is, generally in the ensemble world, we're thinking a bunch of weak learners are going to come together and form a strong predictor, right? And I'm not a fan of that way of thinking, right? What we're trying to do is actually build a bunch of strong domain predictors, take a bunch of strong domain predictors and combine them together to make a strong multi-domain performer, right? So, what are some common multi-domain situations? When I say multi-domain, what do I mean here? A big one that is very obvious is multilingual audio. Each language is a domain to be targeted, right? English and Spanish are very common together. Depending on the region of the world, you may get, various dialects together, et cetera, et cetera. But there are a lot of other use cases. Obviously, the conversational AI world has a ton of great multi-domain examples. Each topic can be thought of as a domain inside of conversational flow. Ordering solutions are a great example. You've got the products, the lingo of the company versus the delivery instructions and the payment instructions. Another one is like a professional environment. Picture a doctor's office. They're talking about, oh, it hurts when I go like this, doc, or very specific technical, descriptions of femurs and things like that. But then they'll break into a general, oh, how was it? Oh, the weather's been great. All these, general stuff. So you've got a domain of the medical domain, very specific stuff you likely want to pay attention to, but that general conversation kicks in. And it's not that you are necessarily trying to target the general conversation, but getting it wrong can maybe throw off a lot of your system. So it's good to have that fairly accurately transcribed too. So how do you combine them? All right, here's the big reveal. It turns out that when you do an end-to-end transcription, end-to-end training, ASR models generally know when they're out of their comfort zone. And what I mean by that is, again, every single, stack is slightly different, but generally you can get some sort of confidence score in the transcription as you're going along. And that confidence score drops dramatically and when it's out of its comfort zone. Especially two models that are trained using very similar technology. They're directly comparable without a lot of tough tricks to figure it out. So in our own stack, we have a confidence score per word. And the simple thing that comes to mind first really does work well. And that is just, segment by each word with the time domain, look at the confidence, and then rank them. And this is because we've specifically targeted these things towards to be strong domain performers. And when we did that, they instantly became weaker general performers and performers in the other domains. So it's very natural, and it works very well that they know their domain and predict confidently when they're in it and predict weakly when they're not in it. And then something that was targeted towards that other location now gets to take over and do the prediction. So let's just go over a quick example of what something like that would look like. In this case, we've got three different strong domain predictors. We have highly targeted number domain prediction, an address domain, and also an order domain for fictitious ordering. Just your in general ordering joint somewhere on the corner, right? So the user may be saying something like, I would like fries and a chocolate shake, please, delivered to 25 Golden Lake Road, Smallville. And, the general order predictor, it has a bit of general vocabulary in it. So it's going to pick up, well, first of all, it's going to pick up the order correctly. And it may know things like deliver it to and stuff because that's kind of general, but it didn't really get anything about the numbers. It didn't get anything about the actual address. It kind of bit off on the N and Lake Road and Smallville, but it did so weakly because it's not confident at this point, right? The number domain predictor was really strong on the 25 because that made sense, but it's weak on the 2 before it because it wasn't sure if that was a number or not. But being a strong number predictor, it weakly predicted that as opposed to strongly predicted that, and it was very easy to tell that it wasn't good. And the address domain predictor knows all those crazy words of street names and cities and et cetera, and strongly bites off on them, but it doesn't have the numbers as well, although since it's a number or an address predictor, it's got a bit there. So each of these pieces were put together by the predictor just simply by looking at their time domain and picking from the best one, you know, which one have the strongest confidence level inside of off of its prediction. So what's the take home from all of this? This is a short talk, so you know, going into too much more detail than this is it's a little bit of a challenge. But you know, I think that the big take home from here is this: you can do a custom training just on a model, and that generally gives you a really good boost. You know, a relative 10% better than the model you started from. So if you have a strong general predictor and it's doing okay, you can get a couple more absolute percentage points, or roughly about 10%, with just a few hours of training data. Obviously, more training data will really help. But with using an ensemble approach, you can not only increase that 10% on your average general cases, but in some use cases, you can make something viable that wasn't before. And the example is the multilingual world. If you've got Spanish and English, you're not sure which one to accept at a certain time. Now suddenly you can focus on building a great English model and a great Spanish model without having to find multilingual transcripts and audio and work that world, which is incredibly hard if anybody has tried doing that. And you can combine those together and answer a use case that is pretty hard to do otherwise. And there's quite a few things of that nature. The address one is an example. It's very hard to train a model to do everything. You know, you need one that trains on addresses. You need one that trains on your specific lingo. Put them all together. There is a cost. You're running multiple ASR solutions simultaneously, but generally, if you need this use case, it's definitely worth the cost. And so that's the big huge take home and takeaway here. We're going for a high level accuracy and going to enable use cases that you just can't get to with a single model effectively. I think that brings us to the end of the talk. I see some extra questions here. I'll try to answer those offline, but I really appreciate everybody's time, and it's been a fun time for me.